Hello class and welcome to lesson 4.2. Today we're going to be looking at odds. Before we get to odds, which is a characteristic or part of probability, we are going to do a couple warm-ups. So let's take a look at review from last day. If you pick a card from a standard deck, so from a standard deck we automatically know that number in our sample space is 52. What is the probability that you will get a face card? Okay, so we've got to take a look at that. So number of faces. Okay, so always put your desired income in brackets. You can either use words or you can draw a diagram. It's okay, as long as we know what it means, or you know what it means. Okay, so number of faces, well, there's 3 per suit times 4 suits, which gives you 12. If you're not sure, there's a jack, a queen, and a king for each suit. Okay, so now we can take a look. Probability of face equals 12 over our total 52, which, oops, sorry, my fault, 52, not 15. Okay, and then just use your fraction button to put it into lowest terms, 3 over 13. If you don't have a fraction button, please see me and I'll show you the long way to do that. All right. Number 2, if you roll a die twice, okay, what is the probability that the sum is divisible by 3? So, ladies and gentlemen, this one's not easy to do because you've got to consider all the possible sums you could have with 2 die. So, the strategy we use here is called an outcome table. So, use outcome table. This may be new to some and it may not be. I can't quite recall. So what I'm going to do, folks, is I'm going to set up a little chart here. And I'm going to write sum on the diagonal, or in the square box here, which represents one possible thing you could do with 2 die. You could sum it, you could do a product, you could do the face value. So one die is going to be 1, 2, 3, 4, 5, and 6. Okay. And we'll let that be the green die. Okay, and say I had a green die and a red die. It's not Christmas, but we'll just do the colors anyway. Okay, now if we're summing them, we're going to be kind of, if I fill my lines in nicely. Okay. Let's take a look here. Okay, so folks, you're going to see a patterning here, so it won't take you long once you do it. So 1 plus 1 is 2, and 3, 4, 5, 6, 7. So I'm just summing along. And you know what that pattern does? That gets repeated on the way over here, too. So I'm just kind of repeating a pattern as I go. So 2 plus 2 is 4, 5, 6, 7, 8, 5, 6, 7, 8. So just keep filling this in, folks, and you'll notice a pattern with the diagonals, actually. Hopefully you guys are already recognizing it. So another way to do this is to fill in the diagonals. Now this is just for summing, folks. If we did a product, it'd be a different type of patterning, right? Okay, so I filled in our chart, okay? And let's go over, first of all the total possible number of outcomes we could have. Okay, so number in my sample, well, how many boxes did I just fill in here? Well, 6 times 6, which is what? 36. Okay, so that's the total number in our sample. Now let's take a look at our outcome, which will be capital A. So our outcome, our desired outcome we're looking for, is a sum that is divisible by 3, right? So when I count numbers, 1's not divisible by 3, 2 isn't, but 3 is, 6 is, 9 is, and 12 is. Okay? 15 is also divisible by 3, but does 15 appear on our outcome table? No. For example, can you take 2 die and get a total of 15? Not if they're faced 1 to 6, which are standard die. And we'll assume they're standard die unless otherwise stated. If you want, you can ask Miss R to show her your fancy die. I've got die that go up to 30 sides. Okay, so I can show you some fancy die. Just ask me in class. All right, so let's take a look at how many times these things occur. So number of times we see a sum that's divisible by 3. It's another way of writing it. Okay, equals, we'll look on our chart, how many times do we see 3? We see it twice, so it's going to be 2 plus, how many times do we see a 6? 1, 2, 3, 4, 5. Again, I'm going on the diagonal, so that's the 6. How many times do we see the 9? Okay, 1, 2, 3, 4. Okay, and how many times do we see the 12? Okay, 12 only occurs once. Okay, so add that up, and that gives us 12. So now we know that the probability of a sum that's divisible by 3 equals 12 over our total, which we have written down right here, over 36. Lowest terms, ladies and gentlemen, that's 1/3. Okay, and to finish off, if you roll two die, what's the probability that the sum is not divisible? So that's the complement or the prime, ladies and gentlemen. So you would say probability of sum not divisible by 3 equals 1 subtract the probability of the sum being divisible by 3. So that was the complement we learned yesterday, right? Or last class. 1 subtract the probability, which we have the answer up top, 1/3. So there's a 2/3 chance that it's not divisible by 3. All right, let's take a look at our lesson now, folks. Let's get into odds. Okay, now odds is different than probability, even though it's under the probability umbrella. Okay, so let's just review probability. So probability is the number of ways to get A, okay, divided by the total number of ways. Okay, just like we did in the warm-up. Okay, so this compares the event, so it compares event to the total. And we're going to learn right now, and this is a lot of people misinterpret this in society. The odds are different, okay? So the odds are the number of ways to get A, okay? But it's not divided by the total, it's divided by the number of ways to not get A. Or in other words, A prime, okay? So that's why we kind of did the complement yesterday to get you understanding it, okay? So it's a different type of formula, okay? All right. Okay, and to find the complement, if you're not sure, you take the total number of the sample and subtract the number of the possible outcomes, which we discussed yesterday. Okay, now you're going to see other terminology, and I just wanted to make sure you fit this in the box as well. Odds against. Okay, so we're just kind of going to flip that fraction. So the odds against are, okay, so if the odds against are, what's the chance of it not happening over the chance of it happening? Okay. So again, that's the complement of the odd. All right, let's take a look at some examples here. Okay, make sure you have that in box and make sure you know how the difference between probability and odds. And remember that this one, so probability compares the event to the total, whereas odds compares the event against the complement, not against total. Okay, so against the complement. Okay, so that's the biggest difference between probability and odds. And I know in society we see it interchanged, and I kind of wish we could have some numeracy education on that, so you could help with that. Okay, so what are the odds of drawing a face card from a standard deck? Okay, so we remember from last class, if not, or sorry, from warm-up, number of face is 12, which is 3. Remember, there's a jack, queen, king in each suit, but 3 times 4 is 12. Okay, so if you need that, put it in there. Okay, so the number of not face, okay, which is the prime, okay, so if you want to put down number of not face, okay, that is the total. So you take the total number of cards, subtract the number of face cards, which are 40. Okay, so now we can do the odds. Okay, so odds, Okay, they don't have a capital P. It's just write down odds. So the odds of face equals the number of face divided by the complement or number of not face, or you could say face prime. It doesn't matter to me. You'll see them written both ways. Okay, so number of face cards is 12 against the number of not face is 40. Put in lowest terms, 3 over 10. Okay, so you may see it that way, or you may see it 3 to 10. So your odds are 3 to 10, or you may see it 3 semicolon 10. Okay. Most of the times, folks, you'll find it's easier to express in a ratio. Easier for people to understand. So easier to express as a ratio. And when you take a look at lottery tickets on the back, they have to express the odds. So the odds of winning this could be 1 in 1 million, for example. All right, let's keep going. Example 2. Odds of a hockey team winning their championship are 5 to 2. Okay. Are they a good team? Well, what do we know? We know odds are 5 to 2. So if this is the odds, this is the win. Okay, and this is the numbers of not win or lose, right? Okay, which gives me how many total? So number in my sample is totaling them up, right? Because either you win or you lose. So that's 7. Okay, so are these a good team? Okay, well, take a look. What's the probability of them winning? Okay, so the probability of them winning, so probability of a win, okay, equals probability of winning, which is how many wins they had, 5, over the probability, which is total, number total. So 5 out of 7, does that mean they're a good team? Yes. Okay, so yes, they are a good team since they will win 5 out of 7 games. Okay. So, oh, folks, it says, what is the probability of them winning? I apologize, I did that already. Okay. Okay. So we know probability of win is 5 over 7, because we just did the winning over the total, which if you want, some people, statistically speaking, like to put that in a decimal, so 0.71, and then they probably say, therefore, you have a 71% chance of winning. Okay? All right, moving on. Last example. What is the probability of winning a hand? Oh, sorry. The probability of winning a hand of blackjack is 0.485. What are the odds against winning? So be careful with that, because it's not really the odds of winning, it's the odds against winning. So I don't know why people ask that, but you know, what's the probability of you losing? Well, in gambling, guess what? The probability of losing is higher than the probability of winning. So that's why we do this. Okay, let's take a look. What do we know? We know that the probability of winning, okay, which equals the number of wins over the number in our sample, equals 0.485. We can change that, okay? In order to assess this, we need to change it into a fraction, so then we can figure out what's our sample. So how do we eliminate the decimal? Well, we are going to times make it out of 1,000, because our last decimal place is in the thousandths column. So it's going to be 485 divided by 1,000. So I'm just going to put down here that we need whole numbers, okay, to assess the fraction. It's too hard to assess in a decimal. Okay, so now that we've got that, ladies and gentlemen, we now know the number of wins over the number of totals. So the number of ways to lose, okay, equals the number in our sample, subtract the number of wins. which from probability we can figure out. So the number in our sample is 1,000. We're going to subtract the number of wins, which is 485, which tells me, hey, if we only win 485, we lose the opposite of that, or the complement of that, which is 515. Okay, so now we can calculate. What it's asking. Okay, so the odds to not win, or the complement of winning, if you want to put that down, equals the numbers that you lose compared to the number that you win. Okay, so that's going to be 515 to 485. Again, use your fraction button to lower this into lowest terms. So 103 to 97. So that's the odds against winning, or the odds of not winning, which is the odds of losing. All right, here's your homework. Page 318, numbers 1 to 5 and 10A. Have a great day and see me if you need any help.